Welcome to this video on the general multiplication rule. After watching this video, you will be able to define the terms dependent and independent as they relate to probability, identify events or trials as dependent or independent, state the multiplication rule for dependent events, and apply the multiplication rule for dependent events. This video assumes you have already watched the videos on basic probability, the multiplication rule for independent events, and conditional probability. If you do not have an understanding of these concepts, please watch these videos before proceeding to watch this video. Independent versus dependent events. Two events A and B are independent if the occurrence of event A does not change the probability of event B. Trials done with replacement are considered independent. Two events A and B are dependent if the occurrence of event A changes the probability of event B. Trials done without replacement are considered dependent. The general multiplication rule. If two events are dependent, we cannot use the multiplication rule for independent events. Instead, we must use the general multiplication rule, which states the following. The probability of A and then B occurring is equal to the probability that event A occurs times the probability of B occurring given that event A has already occurred. Notice that this notation is read the probability of B occurring given that event A has already occurred. This is called a conditional probability. To learn more about conditional probability and to become more familiar with this notation, please watch my video entitled Conditional Probability. General Multiplication Rule Example 1, Picking Cards Without Replacement. What is the probability of picking two aces in a row without replacement? As you can see, there are 4 aces in this deck of cards, and if you recall, there are 52 total cards in a deck. So suppose a student states that the probability of picking 2 aces in a row without replacement is 2 out of 52. Because you are picking 2 aces out of a deck of 52 cards. Is this student's argument valid? Is this the correct probability? Unfortunately, 2 out of 52 is incorrect. Picking 2 aces in a row represents 2 different trials. What's happening is that we're first picking one card out of 52, and then we pick another card. Because there are 2 different trials, there are going to be 2 different probabilities, which have to be multiplied together to find the overall probability of the event. So let's get started. First thing we need to observe is that the phrase without replacement was used in the original question. So that means that we have events that are dependent and therefore we cannot use the multiplication rule for independent events. We have to use the general multiplication rule. Again, that says that the probability of A and then B occurring is equal to the probability of event A occurring times the probability of event B occurring given that event A has already occurred. So when we put this into the context of our card drawing problem, the probability of picking an ace and then another ace is equal to the probability of picking an ace times the probability of picking an ace given that one ace has already been removed from the deck of cards. There are 4 aces in a deck of 52 cards, so the first probability is just a basic probability. There are 4 possible ways to pick an ace out of 52 cards, so we have 4 over 52. As you do these problems, you might find it useful to reduce fractions before putting them into the overall equation because it's just going to make your math a lot easier. But what about the second probability? What is the probability of choosing an ace given that one ace has already been removed from the deck of cards? Well, let's go back and look at the sample space to answer this question. Here's the original sample space. Once we remove one ace out of the sample space, our new sample space will look like this. How many aces remain in the deck? You can see that we've taken 1 away from 4, so 3 aces remain. Now, how many total cards are remaining in the deck? Well, we started with 52, we took 1 away, so now we have 51 cards. So the probability that you pick an ace, given that we've already removed one of the aces from the deck, is 3 over 51. Again, we're going to reduce that to 1 over 17th because that's going to make our subsequent math a lot easier. So we pick up where we left off. We had already calculated the probability of an ace, and now remember we also just calculated the probability of picking an ace given that one ace was already removed from the deck, and that was 1/17. So we're going to put 1/13 into our first probability. We're going to put 1/17 in our second probability, and then remember when you multiply fractions, we just multiply across, and you get 1/221. This is about 0.5%. Example 2. What is the probability of picking 4 aces in a row without replacement? Here you see that we have 4 aces to begin with out of a total of 52 cards in the deck. So when we begin, the probability of picking our first ace is just a simple probability. It's 4 out of 52. Now we've removed one ace from the deck. So the second ace, when we go to pick that, there are only 3 aces left to choose from, and there are only 51 cards left in the deck. So the second probability is 3/51. When we go to pick the third ace from the deck, we've already removed 2, and so we only have 2 aces to choose from, and we've reduced the number of cards in the deck to only 50. 2/50 reduces to 1/25. When we go to pick our fourth ace, there's only one ace left in the deck of cards, and there's only 49 cards left in the deck in total. So the fourth probability is 1/49. What do we need to do with all 4 of these fractions? Pause the video and see if you can write down the correct answer. What we need to do is we need to multiply all 4 of these fractions. When we do that, we get 1/270,725. This is a tiny probability. As you can see, it's 0.0000369 approximately, or about 0.0004%. In other words, it's very unlikely that if your cards are randomly distributed that you would pick 4 aces in a row. Can you figure out the probability of picking 5 aces in a row from a standard deck of 52 cards? Pause the video, write down your answer, and then unpause it to see if you're correct. There are only 4 aces in a standard deck of 52 cards, so picking 5 aces in a row is an impossible event, meaning it has a 0% chance of happening. Example 3. What is the probability of picking a club and then a spade without replacement? So first we're going to rate this in terms of the general multiplication rule. So that says that the probability of picking a club and then a spade is equal to the probability of picking a club times the probability of picking a spade, given that you've already taken a club out of the deck of cards. So to begin with, we have 13 clubs in the deck of cards out of 52. So the probability of picking a club is 13/52, or 1/4. And hopefully you can see by this graphic that a quarter of the cards here are clubs. What about the probability of picking a spade, given that we've already picked a club out of the deck? So let's just imagine we happen to pick the 5 of clubs. It really doesn't matter what number or letter is associated with the card. But the point is we've removed one card from this deck. How many spades remain in the deck? Well, we still have 13 spades because we didn't remove any spades from the deck of cards. So we have 13 spades, but how many total cards are left? There are 13 spades to choose from, but there are only 51 cards left in the deck. So the probability of picking a spade, given that one of the clubs has already been removed from the deck, is 13/51. 51 because we already removed one of the cards from the deck. So going back to our original equation, which is the general multiplication rule, we find that the probability of picking a club and then a spade without replacement is equal to 1/4 times 13/51. This gives us 13/204, which is approximately 6.4%. Example 4, picking marbles from a jar. Suppose there are 10 marbles in a jar with the colors as follows: 1 white marble, 4 blue marbles, 2 purple marbles, and 3 yellow marbles. What is the probability of picking 2 purple marbles in a row without replacement? The phrase without replacement was used so the events are dependent. Therefore, we must use the general multiplication rule, which states that the probability of event A and then event B occurring is equal to the probability of A times the probability of B, given that A has already occurred. Putting this in the context of the problem, we find that the probability of picking a purple marble and then another purple marble is equal to the probability of picking a purple marble times the probability of picking a purple marble, given that one purple marble has already been removed from the jar. So first of all, the probability of picking a purple marble initially is just 2 out of 10 because there are 2 purple marbles. So there's 2 ways that you could pick a purple marble out of 10 total. So we have 2 over 10 and we reduce that to 1/5. Now we've removed one of the marbles from the jar. So what is the probability of picking a purple marble now? Well, you can see that there's only one purple marble left, so there's only one way that could happen. And if you count, there's only 9 marbles left in the jar. So therefore, the probability of getting a purple marble after one has been removed is 1 over 9. Putting them into the general multiplication rule, we have 1/5 times 1/9. That gives us 1/45, which is about 2%. Example 5. What is the probability of picking a white marble and then a yellow marble without replacement? The phrase without replacement was used, so the events are dependent. Therefore, we must use the general multiplication rule, which states that the probability of A and then B occurring is equal to the probability of event A times the probability of event B, given that A has already occurred. Putting this in the context of the problem, we have the probability of white and yellow is equal to the probability of white times the probability of yellow, given that white has already been removed. So to begin with, as you can see, there is only one white marble. So there's only one way we could pick a white marble out of this jar, and there are a total of 10 marbles. So our first probability is simply 1/10. Now, once we remove that, how many yellow marbles are left? We didn't remove any yet, so we still have 3 yellow marbles. However, we did change the total number of marbles in the jar. There were 10, now there are 9. So now the probability of picking a yellow marble is 3 out of 9. Again, it's always a good idea to reduce your fraction when you can. 3/9 reduces to 1/3. So putting these two fractions into our overall equation, we have 1/10, which is the probability of a white marble, times 1/3, which is the probability of picking a yellow marble after we've already taken the white one out. And that's 1/10 times 1/3, that gives us 1/30, which is about 3%. Example 6. What is the probability of picking 4 blue marbles in a row without replacement? Again, we said without replacement, so the events are dependent. Therefore, we have to use the general multiplication rule. Notice that there are 4, 1, 2, 3, 4 events, so we're going to have 4 fractions to multiply together. Let's get started. The probability initially of picking a blue marble is 4 over 10. To begin with, we have 4 blue marbles and 10 total marbles. Again, we're going to reduce this to 2/5 to save us some trouble later on. Once we remove one of the blue marbles, how many blue marbles are left? We have 3 blue marbles left and a total of 9 marbles left in the jar. So the second probability is 3/9, which can be reduced to 1/3. We remove another blue marble, and so now we only have 2 blue marbles to choose from and a total of 8 marbles in the jar. So we have 2 over 8, which we reduce to 1/4. Lastly, we remove one more blue marble. So you can see here there's only one blue marble left. So we're going to have 1, and if we count them, there are only 7 marbles left in the jar. So the last probability is 1/7. What should we do with these 4 fractions? If you said to multiply them, then that is correct. Doing that, we get 1 over 210, which is about 0.5%. Having watched this video, you should now be able to define the terms dependent and independent as they relate to probability, identify events or trials as dependent or independent, state the multiplication rule for dependent events, and apply the multiplication rule for dependent events.